Hello and welcome to Edu-Malanga. On this channel, we create free tutorial videos for the Matric Mathematics syllabus of South Africa. Today we are wrapping up quadratic sequences. Quadratic sequences is the last lesson in the first unit of the year. The first unit of the year is patterns, sequences, and series. And today we will be doing one last example. The example we will look at asks us to find the general term of this sequence, and the sequence is 1, 3, 10, 12, and 39. So the first thing we do when we get asked a question like this, I know that in this video you know that it's a quadratic sequence, but you may not know this in your test and exam, so the first thing you would have to do is to check and find out what kind of sequence are you looking at. To do this, you have to rule out the two other sequences that we looked at, which is the arithmetic sequence and the geometric sequence. Let's start by ruling them out. An arithmetic sequence has a common difference. So that means that the difference between all the terms would stay the same. So let's take a look at what happens with our sequence. We have 3 minus 1, that would be 2. 10 minus 3 is equal to 7. So you don't have an arithmetic sequence because the first difference was 2 and the second one is 7. That means that the first difference is not common. Now let's rule out the geometric sequence. We're going to have to do some division for this one. For a geometric sequence, you have a common ratio, and to find out your common ratio, you divide two terms that follow each other. So let's do that. For example, we would say r is equal to 3 divided by 1. That is term 2 divided by term 1. That's equal to the number 3. And then if we look at term 3 divided by term 2, that's equal to 10 divided by 3. That's equal to 3.33, and it keeps on going. That's obviously not a common ratio. So again, you know you don't have a geometric sequence. That leaves you with one last type of sequence, and that is the quadratic sequence. Let's check to make sure that the sequence is quadratic. I'm going to rewrite it. Tn is equal to 1, 3, 10, 22, and 39. So let's check to make sure that we are looking at a quadratic sequence. We're going to do the calculation. 3 minus 1, that's equal to 2. 10 minus 3, that's equal to 7. 22 minus 10, that's equal to 12. And 39 minus 22, that's equal to 17. Okay, so that is D1, the first difference for this quadratic sequence. Let's get now the second difference, D2. 7 minus 2, that's equal to 5. Okay. 12 minus 7, that's also equal to 5. Yes. And 17 minus 12, that's also equal to 5. So yay, our second difference is common. So we know that we are looking at a quadratic sequence. The general term for a quadratic sequence looks like this. You have Tn is equal to a times n squared plus b times n plus c. And we know how to solve for the coefficients a, b, and the constant c from the previous lesson. If you're watching this video for the first time and you don't know how to solve for a, b, and c, I suggest you go back and you watch the previous video. On that video, we introduce quadratic sequences, and we also find out how you solve for a, b, and c. You'll then be able to follow with us today. Let's get started. We'll start by solving for a, and we will call that our step 1 because we're going to do this in 3 steps. So to solve for a, we use the formula that 2a is equal to d2. So 2a is equal to the second difference. Therefore, a is equal to d2 over 2. Let's come back to when we did this calculation to make sure that we're looking at a quadratic sequence. Our d2 is equal to 5. So then we'll say D2 is equal to 5. Therefore, A is equal to 5 over 2. Okay, we'll leave it as this, and we've now solved for A. The next step, we solve for B, which is called step 2. And to solve for B, we use this formula. 3A plus B is equal to term 2 minus term 1. If we come back to this again, term 2 minus term 1 we solved for already. We said that's equal to 2. So let's just write down under here that this is equal to 2. Our A we solved for, and we said A is equal to 5 over 2. So let's substitute into this equation then. We're going to have that 3 times 5 over 2 plus B is equal to 2. We're going to move this to that side of the equation. We will then have that B is equal to 2 minus 3 times 5 over 2. Let's do the multiplication. 3 times 5 is 15, so we're going to have 2 minus 15 over 2. And if we make 2 into a fraction with a denominator of 2, we will have 4 over 2 minus 15 over 2. That therefore means that B is equal to 4 minus 15, that is negative 11 over 2. And that's the solution for B. Now we need to find C, which is the last step. Step 3, we solve for C. And to solve for C, we use this equation. A plus B plus C is equal to 1. Let's rearrange the equation to make C the subject of the equation. We will then have that C is equal to 1 minus A minus B. Our A is equal to 5 over 2, and our B is equal to negative 11 over 2. Let's substitute them into the equation. What we get is that C is equal to 1 minus 5 over 2 minus, open brackets, negative 11 over 2. These two negative signs are going to turn into a positive sign, which you will then have as 1 minus 5 over 2 plus 11 over 2. Let's turn this 1 into a fraction with a denominator of 2. We're going to have 2 over 2 minus 5 over 2 plus 11 over 2. So then our C is going to equal to 2 minus 5, that's equal to negative 3, plus 11. Negative 3 plus 11 is equal to 8. So that's 8 over 2. 8 over 2, well, that's equal to 4. And we've now solved step 3. We can then come back to the general term. Our general term was Tn is equal to A times n squared plus Bn plus C. Let's substitute in A, B, and C because we've solved for all of them. Our general term for this quadratic sequence is Tn is equal to 5 over 2 n squared minus 11 over 2 n plus 4. And we've now solved example 1. I hope you understood everything that we did. I know that there was quite a few equations. Each step went with a different equation. Try and remember them. Try and understand how to use them. Thank you for joining us today. We will do one more video on patterns, sequences, and series, and then we will move on to a new unit.